So there are still a few things I could improve here. For example, I have the pull downs and the resistor divider that belongs to the Hall sensor, to the second Hall sensor, is currently placed here. But I think it would be better to place it close to the pins and then have ESD protection in the back. So we can place this one actually in the back and also somewhere between the, let's see, so let's place the resistors first actually. So we have the resistor there and we have a resistor there. Which ones? Okay, that one and that one. So I'm going to place the resistor close to the pins first. We have this one, and then the second one is seems to go there. They have to be like this because I'm very limited where I can place, where I connect the Hall sensors, because I'm using as many peripherals. I'm almost using all of the peripherals on the STM32, and so I have very limited possibilities to remap the pins. Let's see, what is this? This is the regulator. Right, this is the VREF. So the VREF will need to be, let's see. Yeah, the VREF needs to be close to the ADC supply, the 33 and 32. These two. But the reset switch doesn't need to be anywhere close. Anywhere near as close. So this one is, this is for the VREF, and this is the filter for the VREF. So we could place these capacitors in the back together with all the other bypass capacitors and free up a little bit of space here at the top. And that will be actually very good because we can have a via then. We can have a little bit more space for a via there. And this will then go right here. And the regulator right beside the ferrite bead. This will be the output capacitor on the regulator, which is right, okay. And I also have the VREF connected to the DRV chips, which maybe isn't the best solution actually, because we are going to have long traces going there. It's maybe better, I think, it's actually probably better to have two more regulators, where each one is actually on the area of the motor control circuit here. But let's place this one first. So this one has a capacitor there, and then we have the VREF that connects to the ferrite bead and goes to the reference voltage there. So we can essentially place, let's see, what do we have here? We have EDD MCU and we have and we have the voltage sensing input. So it's likely that this voltage sensing input will need to be let out on this side. So I'm going to reserve a little bit of space for it. Let's see here, what is this? This one could actually be right. This one actually belongs to the VBAT pin, which is pin 6. Pin 6 is here somewhere. No, where's pin 6? Here. No. 21, 22, yeah, here. So this one belongs to pin 6. And what is this then? So sometimes when placing the bypass capacitors, it's easy to place them in slightly unreasonable ways, where you actually end up placing them by the wrong pins. There's nothing wrong with the connections, they're just placed in a way that's different from the way that is intended in the schematic. So I think it's better to place things so that if this one is sort of connected directly to the VBAT pin here, even though it also connects to VDD through 3MCU, that this particular capacitor then is placed directly by the VBAT pin. But I could actually have one capacitor too many here, because I have a capacitor by every single power pin. So it's possible that I could actually remove this C3 capacitor, unless, what is pin 144? Oh, unless there is another power pin here, which I haven't. Which one is 143? What is pin 143? Would that be the reset or something? PDR on. Okay. So this capacitor takes care of that connection. So yeah, I think this capacitor can be safely removed. I think I have one too many. Maybe. So 108, is that a power pin? Yeah, okay. So actually, this capacitor should go there, like this. Let's see. And this one is the V cap, so it can go right beside there. I'm going to move them a little bit away from this row, so I can have a little bit of space for vias, and then the via will go here and to the pin. Okay, so that makes sense. Maybe even like this. And it's a good idea to flip this one because there are a lot of connections that are connected to pins beside this capacitor. So it's better to have it in the back so we don't have to route around it. This would be the UX connector. It connects, pretty much all of the connections are actually here, so very nice. Very good placement of that one. And then we have the other pair, the last pair of the resistors, which will connect here. So we have HAL B and HAL C. Right, so this can go on the top here. And what is this? This is the input capacitor for regulator. HAL C2 will go right. It's quite possible that it would actually be better to place this on the back. All of them actually, because then I'll just place the ESD protection in the back as well, and maybe will not even require any vias to connect the diode to them. Let's see, flip this one as well and rotate. Yeah, something like that. Highly annoying that I cannot move properly if I move both of them at the same time. Okay, like that. And the last is the protection then. This one. This one can then go, let's see. So all of them are actually right beside each other. A2, B2, and C2. So that means that I could actually place the ASD protection at the top. Let's rewire it. Could make sense actually. What if we place it there? Move this one a little bit. And we we could actually rewire C2 to be A2. So it doesn't matter here. It's just ASD protection. It doesn't matter which lead it goes to. So C2, so anything that's A2 on the MCU will go to pin number 4. Let's see. And B2 will stay the same. And pin number 1 will be C. Let's see. We should also do this as well. So this will go to C2. Like that. And this one then can go to it can stay there, but I can rotate it like that. That's better. Okay, so now we can connect them. Sorry, this will be a much thinner wire. And then what is this? Right, this is connected. They're connected together. Slightly thicker wire for the reference supply. It's not a really high current supply. It's just to keep the impedance down. I should have probably also checked that I have enough space for all the labels. Let's go to the top layer. A little bit crowded there. It is recommended that pins should never be routed out of the side of the pin. Let's see the ground here. This needs to be. That would have to do. It's pretty short anyway. It's like at this magnification, this is actually 2 millimeters. Okay, not very short. Can I lead it out here maybe? Oh, I can. Awesome. That's better. now the annoying part of having to delete that and redo it. And the grounds for all of them there. Perfect. Hull C goes there, and this goes to the hull sensor there. Right. This is a bit long, but it's also a rather slow signal, so it should be fine anyway. This one goes there. I'm using a bit too thick trace now. I forgot to change the thickness. Alright. Should probably start from the pin and go to the via. Get better connection that way. VDD3A3. So avoid any artifacts. I'm going from the pin to the via. I have the crystal and this would be the crystal input actually. Right, so this is better. Let's see. It's actually better to rotate the crystal, isn't it? And move it a little bit closer there. What is the idea of wiring the crystal this way in the package? Like, why not take two adjacent pins? Why do they have to be across? Does anybody know? And this one can go. Actually, I think this resistor can go in back. I try not to place too many components in the back. I just place the components that are kind of helper components. So I place all of the main components on the top, and things like ESD protection, for example, the bypass capacitors, anything that I may not need to, anything that I don't have to probe directly. So, for example, the ESD protection is connected also to the resistors at the top layer there. It's a little bit like in this case here, I have the resistors in the back, but the ESD protection at the top. So it's easy to probe the ESD protection. It's much harder to probe pins directly on the MCU. and I'd rather not do that. But since I have the ESD protection at the top here, I can easily probe the signals here. And the reset pin also is connected to the button there. So placing this resistor in the back is perfectly fine. No implications. Doesn't make probing harder. And all of the connections need to go in the back there to ground. $543 unrouted nets. I can get rid of a lot of unrouted nets by just doing this. And I place this ESD protection here because I want to, since I have connections both here and on the other side, I want to place it somewhere closer to the middle. I think it's time to actually have a look at all of the designators because they're just a total mess right now. Let's place the designators. I changed the size of the text to 0.6 millimeters. If you want to change the size of the text of the designators, you can go to edit, set, let's see, yeah, set footprint field sizes, and then you can just click the reference designator value user defined. I use the same size for all of the text. Alright, that's fine. It's a little bit messy here. It's because of the test points. Actually, all the test points, this is actually wrong because all the test points have to go at the top. Let's flip them. That's much better. And I have to show the footprints on the front, and I'll just place the test points here. Or maybe I should actually place them there. I have a little bit of space here. Oh, no, actually, here. Exactly here. No! This is annoying. I wonder though why I didn't move them close. There's a space for one test point. I think I moved it away somewhere, and then I forgot to move the others. Could I actually grab this? Let's see, G. No? I can only grab vias, it seems. I can't grab a footprint. So I have to do it like this. And this one is locked now, because it's too close to this one. This is the situation in KiCad where you can't move the track because it's because it has been overlapping this footprint. It's so annoying because sometimes you don't know where it's overlapping. The only way to find out is to run DRC. but you can't move it. You can't just like move it away. You have to first move out the part that is obscuring it, and then you can move it away. I'm gonna delete this. It's very nice to have the test points aligned like this. So all I have to do probing is just to stay in one place on the PCB and probe each test point in turn, instead of having to find the components. So this goes here. I would kind of expect it to remove that bit, because that is actually, although I think it classes it as a dangling connection, so it can't really tell if you have, like, if I route like this, then it can tell that I'm routing the same connection, so it can remove it. But if I have a dangling bit, then I think it can't. It simply can't tell that that bit needs to be removed. This one goes here, and this one goes here. There is absolutely no need to use such thick track there. Let's see. Can use a 25 for analog connections. That's better. And I have two test points here. These two belong to the 3.3 volts. So could I actually place them here? This is a current sense resistor. Right. That would be better. Because then I can just place these two at the same row of test points. Yep. Connect the power. Let's use a thinner track there. So let's see, this one goes there, and this one, oh, it's actually better to do like this. So I'll just swap places and make the routing easier. So then this one goes here, and this one goes here. I gotta be careful not to not to wire anything to this lead here, but instead to have a bias going to inner layers and then have the power in the inner layers. Right, so moving back to 35, we have this one. No? Which connection was it? Right, it was this one. This should work fine, because I shouldn't have any connections going there. I don't think so. Let's see here. So if I go to the back layer, let's rotate this one. Got the VDD33, it uses, let's see, actually I'm not going to connect them because I'm going to have inner power layer, so it's better to even leave that one out. And I could even use the inner power layer for the connections to the test points. I'll see. Let's see, so this one and this, right, so this one needs to be 0.5, and we'll connect to this 0 ohm resistor. This is just an extra bypass to use the same power supply for both 3.3 MCU and 3.3, just as an option. Okay, let's have a look. Let's actually continue having a look at the labels. Make sure that we have enough space for the labels before we continue the routing. Where's the label for that one? Where is the label for that one? There. So that seems good. Let's see, could I hide the tracks actually? In the rat's nest. That's better. Okay. Since I changed the size of the designators, I can move them a bit closer. That's fine. Yeah, that's not really necessary. Okay, let's move on to the front. A lot more mess here after moving things around. So annoying that things don't align perfectly by default. Moving them a little bit doesn't affect the tracks. I'll just leave them as they are. Yeah, leave that one and just move this one. We have the test points. This one. Okay, that's fine. This one. Just move them slightly. P8, P7. Yeah, that's probably fine as well. This one. These two need to be moved a little bit. U24. Yeah. So basically just continuing to clean things up here, making sure that everything is aligned and doesn't overlap, and then I'll continue the routing. I think these ones, yeah, there's one. That one needs to be moved here. And I try to keep things symmetric when I have two components that are sort of like the same type of component. Maybe I could actually move that one. No, I'll leave it in place. Just to avoid any kind of confusion. Okay, that's fine. Then I have the larger caps here. And this is, yeah. Right, so I'll just continue doing this, and hopefully I can finish this board pretty soon. Thanks for watching. Bye.